Yeah, that's right.
So today we've got quite a few things to discuss here. We're going to start off with just introducing some basic concepts, probably not too much on OpenStack, but we will look at Murano. I'll spend some time talking about platform as a service and Staccato. And then we're going to dive into Murano and show it actually in action, creating a cluster of Staccato instances or Staccato nodes, and then show how that can be used to deploy applications to Staccato. We'll also look at auto scaling and some of the other things it enables. And then we'll have some time towards the end for Q&A. So feel free to queue up your questions and think of them during this presentation. And I believe there's a facility to enter those into the Meetup. So I'll start off just briefly with an introduction. ActiveState is a company based in Vancouver, Canada. And we've been around for a long time, about 17 years. We've been delivering language packs and for various like Perl and Python and Tickle and other languages for various distributions for a long time. And we also have built an IDE called Komodo, which is very great for dynamic languages. Excuse me. But more recently, we have focused on platform as a service. And we've dove into this with both feet. Platform as a service based on Cloud Foundry. And we've modified and enhanced Cloud Foundry considerably to be fully enterprise ready and enterprise hardened. So what we'll do later on during this presentation is dive into what that actually looks like and how developers and ops people can make use of Staccato on top of any infrastructure, particularly OpenStack. And Georgie, go ahead and feel free to introduce Mirantis.
Yeah, so Mirantis is also a pretty old company. It was established like more than 10 years ago. And like 4 years ago, or even like 5 years ago, Mirantis actually moved to the OpenStack world. And right now, Mirantis is fully focused to be a pure OpenStack player. It means that we do our contribution to all OpenStack components, and we distribute this OpenStack open source version to our clients, and we provide our professional services and support for OpenStack.
Great. And it is definitely worth mentioning that there is an OpenStack Summit coming up in May. I believe it's May 18th through 22nd. And it happens to be in Vancouver, which is the hometown for our company, for ActiveState. Beautiful city. Recommend you go there. And Mirantis will be there, of course, and we'll be there in full. Everybody pretty much in the company will be there at some point. So please show up and you'll be able to meet everybody and learn more. So with that, I'm going to hand it back over to you, Georgie, and you can spend a couple of minutes on OpenStack and then a little bit more on Murano before we get started with the installation. Okay, go ahead.
Okay, so just in case if someone is not familiar what is OpenStack, so OpenStack is open source cloud platform which actually provides control plane API for different resources, for different infrastructure resources like compute resources, networking, and storage. And this is an open source platform and open source project with its own community. And there are a lot of vendors who are actually contributing to the OpenStack by adding support for their specific infrastructure component, software or hardware. So for example, for storages, you can find drivers for different companies like EMC, Meetup. In networking, you will see also some vendor-specific plugins like for Cisco, for Juniper hardware. And for compute, OpenStack supports different hypervisors, including Hyper-V from Microsoft, ESX hypervisor from VMware, and KVM hypervisor, which is open source, but mostly baked by the Red Hat company. So let's move on to the next slide, and I will actually introduce one of the projects which is a part of the OpenStack ecosystem. So we have an application catalog implementation in OpenStack. The name of the project is Murano. Right now, this is a project on the StackForge, and this is a place or a repository for the projects who are being under active development to be placed as a part of the OpenStack ecosystem. So this project is already a part of OpenStack ecosystem, but it's not a part of official OpenStack distribution, which is provided by OpenStack Foundation. So this is open source project which is guided by OpenStack community, and it follows all OpenStack development processes rules. And you can find this repository on the GitHub/StackForge/Murano. And the idea of this application catalog is to actually simplify the onboarding process for applications which should be run on top of the OpenStack infrastructure. And this application catalog actually provides a way for application developers to publish their application and to share their applications with other cloud users. And actually, let's switch to the demo. So it's better to see once than hear like multiple times. So.
Okay, Georgie, could I just ask you one question about this catalog then?
Absolutely,
when you, let's say, select something from this catalog like WordPress, it's taking care of building up the entire infrastructure for you. Is that correct? And you can specify the resource requirements that are needed, for example, the amount of memory and things like that. Is that how that works?
Yes, that is correct. So when application developer uploads an application to application catalog, so it actually uploads specific files like manifest file, which actually defines what is the application and what are the flows to deploy it and what are the heat snippets which should be used to generate heat templates which will be used to provision OpenStack resources. And yes, by that you can actually define the whole stack starting from the infrastructure level requirements, so what are the networking requirements, what are compute storage requirements, and then ending up with the application configuration part, which also will be done by this application catalog.
Very good. That's exciting stuff. Okay, so we might as well see it in action. But before we do that, Georgie, I'd just like to spend a minute describing Staccato because this is the actual application we are going to deploy using Murano in a few minutes. So Staccato is a platform as a service, as I said earlier. It's based on Cloud Foundry. A platform as a service allows you to take an application written in any language and deploy it on any cloud, basically, whether it's on OpenStack or VMware or CloudStack or AWS or anywhere. It's basically in an abstraction layer. So OpenStack is very powerful, but there's a lot of details of working with it that ideally the developer and the development team shouldn't have to get mired into as much as possible. So it puts an abstraction layer on top of that. And this is kind of some of the marketing stuff. It's, I would, instead of talking to these points directly, you can look at them. But I will say that platform as a service is rapidly becoming one of the biggest disruptors in software development in the enterprise today. And most companies are at least moving towards using PaaS. from a couple of years ago when nobody has heard of PaaS. Now it's just it's rapidly being adopted. It's kind of like source code management was, let's say, 10 years ago, where everybody started to hear about it, but not many people used it. Now it's unheard of to build a software project without SCM, and PaaS is kind of moving in that same level. Much faster for getting code out the door, much higher productivity, gives you security, and later on, I'll show you Staccato in action so you can see how this all works together. But I do like to dive a little bit into the architecture so you see what's under the hood. And so everything in the green box is the PaaS. And there's a number of components, just like OpenStack. There's several components that make up the PaaS. There's an API that can be used to control and access and manage this thing. So we expose the API. The cloud controller component on the left is the component that's kind of in charge, and it's exposing the API. And then you use that API as a developer to deploy and provision applications, to determine the health of your applications, auto-scale your applications, check the various other things that are needed. Also deploy data services, wire applications to those data services, and a number of other functions. So the API is used for that by the developers. And then once the application is deployed, the users then access the application in the cloud. The app is running in the PaaS, and then the router takes care of routing and load, and there's a load balancing facility that load balances between the application instances. The apps can be automatically scaled, and a whole bunch of other things which we'll look at throughout this. But I wanted to give you a little view under the hood of what the PaaS that we're going to be deploying looks like. And we also like to say that we are the easiest way to get started with Cloud Foundry. If you attempt to deploy Cloud Foundry by yourself, you'll find it might take a couple of, maybe a couple of mornings work or whatever to get it up and running. And you have to read a lot of manuals and download a lot of packages and clone a lot of things. And with Staccato, it's much simpler. It basically involves just booting up VM instance or a few of them and clustering together. And you'll see how seamlessly that all works with Murano basically right now. So what I'd like to do, Georgie, is transfer, if I can figure out how to do this, transfer the presentation back to you. And
I believe I just need to click share my screen. And
okay.
You need to stop actually sharing.
Okay, I'll let's see here. Oh, I see. Grant control, and I need to find you. See here. Georgie, there's two, you have two entries here. I'm not sure which one to send it to you. I'll just do the first one.
Okay, that's one will work, yes.
That's actually not what I wanted, right?
Yes. Okay, let me. That's interesting.
So you now have I clicked the wrong button. You now have control of my desktop.
Yes, but you should go, I believe, and click the button stop sharing.
Yeah, you need to stop sharing, John, and then Georgie can share his screen.
Okay, and do I do this with the pause button on my controls here? Okay. Oh, I see. Okay, there we go. Stop sharing. Okay.
Okay, now I should be able to share. So are you able to see this window with, okay, very good.
Very good. Yeah, sorry for the interruption.
Yeah, no problem. So this is, this is live environment, so anything can happen. And right now we are OpenStack Cloud, which is hosted on the Mirantis OpenStack Express. So this is actually OpenStack Cloud on demand, hosted on top of IBM SoftLayer data center. And I'm logging into my tenant. Hope it will work fast enough. And here is actually the application catalog, which I showed in the presentation. So here's the main page of application catalog in itself, where you can actually find different applications. So you can actually filter them by application category. For example, here we see the full stack of applications which we prepared for Staccato installation. And we can actually, you see all the main Staccato components represented as application entities in application catalog. So I believe it should be mentioned that Murano application catalog was not designed to replace any PaaS. Instead, this application catalog is actually offers a way to integrate any third-party applications or frameworks like Staccato Cloud Foundry or Pivotal Cloud Foundry or open source version of Cloud Foundry to be integrated and to be accessible for the cloud users. And in the same way, we actually integrated Google Kubernetes, which is a cluster management for Docker containers. And we plan to integrate other components like Mesos and Hadoop, for example. Okay, but let me switch to environments. So this is an orchestration part of the application catalog. So in application catalog page, you can actually browse and find those applications. But once you found an application, so what you can do with them? So Murano provides a high-level orchestration built actually on top of Heat. So Murano uses Heat engine under the hood to provision OpenStack infrastructure resources, and also it can be used to do some software level orchestration. And Murano orchestration engine is responsible to do high-level orchestration of different application components which are not visible for the Heat stack. And here, so I will go and create a new environment, Staccato. So Murano environment is just a logical representation of your multi-tier application. And here you can actually drag and drop different applications and use them as a building blocks to create your complex multi-component application. So let me go
Georgie, could I ask you just one quick question? You said that Murano is capable of doing things that Heat itself isn't. What's one example of something that Murano can manage that Heat is not capable of doing?
Yes. So Murano actually exposes high-level abstractions like application interface, application requirements, and application capabilities. Those entities, they do not exist in the Heat level because Heat level is very granular and it is specific to the resources. So you can see and manage some compute resource, IP address, floating IP, but this is sometimes too low level to define your application dependencies from each other. For example, how you can say that I have my Java application and it requires to have database and Tomcat instance to be deployed on. So in Heat world, you will actually do the full stack definition saying this is a VM which is placed to this network, and this is like software component which should be placed on this VM, and dependency will be between resources but not between applications. So Murano adds additional high-level abstraction to represent more high-level dependencies between applications without actually digging into the resource-level stuff. And I will actually show how this works. So let me start creating a new Staccato cluster. So Staccato has different roles which should be assigned to different nodes. And the main role will be Staccato core, which actually hosts all essential components which are required to have functioning Staccato cluster. So I will drag this Staccato core, and here we see the configuration options which are available for this core. So for example, Staccato uses DNS to distinguish different applications which are deployed on, and to provide layer 7 routing for incoming requests which will come to your Staccato cluster, and based on the host name or the DNS name of the application, this incoming request will be routed to the proper application which is hosted inside your Staccato cluster. And I'm going to use special domain xip.io. So this is a special well-known domain which will actually convert IP address, which is a part of the domain, to the actual IP address without any DNS resolution stuff. So we will...
Yeah, basically, just to elaborate on that briefly, so zip.io, when you create a host name that embeds an IP address and resolve that in the global DNS, zip.io itself will parse the domain name, host name, and extract the IP address and return that. So it's a really quick way to instantly create a host name, and that's what Georgie's going to be using here.
Yes. So I will use this method. And here I can actually specify the image flavor for my VM, which will be created for Staccato core. And I can here specify different options like host name, placement, so where it should be placed, and how I can access this VM via SSH. So I can provide my key pairs to be able to log in via SSH to this host. Okay, so now we have our core, but besides that, there are other roles which we can add to our Staccato cluster. And we can actually add nodes one by one, and we will add one by one VMs with specific roles, or we can add actually clustered versions of role, so that we can create multiple VMs with the same role in one click. So I will actually drag and drop my Staccato cluster, and here I can specify my DA, which is Droplet Execution Agent role for the cluster, and this is the analog of compute node for the OpenStack, but in Staccato world.
The DEA is the Staccato is it's basically VMs that are dedicated to running the application containers, the Docker containers that we run internally to run the apps. So DEAs are dedicated for that.
Yes. Okay, so I can configure the maximum number of nodes which will be in my DA cluster, and initial count which will be actually deployed at the beginning, but then we can scale this cluster up and down during its lifetime. And here I can also specify again the flavor for my VMs in this DA cluster. And the idea is that you can actually specify different flavors for your DA nodes, for core nodes, and data store nodes, because all of those roles are different. So for DA role, most probably you will need to provide more CPU and memory resources, because this is the place where your application will be up and running. But for the data store, probably you need to provide just more memory and storage resources to actually be able to store large amount of data in your databases, which will be bound to your application. And here I can specify again hostname template. So if I create multiple VMs, I will have like a sequence of names like DAZ01, 02, 03, and so on. Okay, click Create. And just to speed up the deployment process, I will deploy this configuration. It looks very simple, but if we go to the detailed topology, we will see that the actual deployments will involve multiple VMs and multiple components, which actually depend on each other. And this high-level application dependency will be managed by Murano application engine, and Murano will make sure that those components will set up in proper sequence. Okay.
So, Georgie, that diagram was showing the all those VMs that it was displaying. That's the maximum number of VMs that you would have allocated. So they're not going to be currently provisioned. It'll start off with the minimum, right?
That's correct. Yes. So we see the maximum number of VMs which are configured, and once we deploy these environments, we will see a green color VM, which means that this one is up and running, and other will be gray, which means that they are not deployed yet, and we are waiting for scale up or scale down action to perform actually addition or extraction of the VM from the cluster.
Great.
So I started the deployment process. So I click a deployment button here, and right now we see the logs from the orchestration engine, which will actually show what is the current status of deployment. And right now it's creating a VM. So let's wait for a while, and we will see that under the hood, Murano generated a hit template on the fly based on the what applications we configured in this environment. And Murano actually asked hit engine to start deployment of this hit template. And hit will be responsible to provision OpenStack resources. And we will see the list of networks, floating IPs, neutron ports, and VMs, which will be used later for the software piece of the orchestration. So one VM is created, which means we can probably go to the orchestration layer, to the stack, and see what's going on. So here is our new stack, which was created 1 minute ago, and it's updated right now. And here we can go and see all those resources. Right now, I believe it created actually both VMs for core and for DAA. And here is a list of other resources which were created by Murano orchestration engine. So as you saw, we did not specify any networking stuff. We just specified that we need to assign floating IP to the core. And under the hood, Murano used the default network topology, which is created here. Yes. So, and for each environment, Murano, by default, will create a private network for you, create a subnet with specific IP address range, class C, actually, network. And it will attach all those VMs to this private network so that you have your isolated networking environment. So this is your isolated layer 2 segment, which will be shared between Staccato nodes. And Murano also created a route between external network, which will be used to expose your entities to the external world, to the internet actually. And this route will be used also by Staccato to communicate with external resources like internet, repositories for Ubuntu, or repositories for Staccato itself, and for application store, which is also a part of the Staccato.
I really appreciate how you can get a visual view of the environment here, both the topology and the network. It's pretty cool.
Okay, so right now we're in the process of deploying core, so it will take 5 to 6 minutes.
Okay.
So I can actually
What I recommend I'd like to do, if you don't mind, is I'd like to see some of the configuration you have under the hood. So you had shown me earlier the YAML files for configuring, and I think that's pretty interesting for the audience. So this is, if you could go into some of that, I think it would be interesting to see it.
Okay. Okay, so right now what you see, this is a workflow definition for the applications. And right now we're looking to Staccato core, and this is a workflow. Actually, this is a set of workflows which will be used by Murano engine to deploy this application. And as you see, for Staccato core, it's pretty simple deployment script, like configure security groups and open the ports which will be used by this application. Then
typically, just to make a point here, Staccato only requires a couple of ports to be open for full operation, which is 8443 for HTTP. You could also open SSH, and that's pretty much it that needs to be exposed from the outside if you're using standard HTTP applications.
Yes, but probably our audience have a question why we see this actually rule which opens all ports. And these all ports, as you see, they are not external use. So we open firewall or security group to expose all ports between Staccato VMs within this layer 2 segment. So Staccato VMs can actually communicate with each other at any ports without any restriction. But this is not external security group, which means that those ports will not be accessible from the outside. So this is only this specific segment security group. And we expose externally only two ports, number 80 and 443, which is like SSL port. And then we just ask our node VM to deploy itself, and actually Murano provides a core library which does all the implementation of the VM management stuff, so you don't need to actually see what is going on for the VM creation. In most of the cases, you just ask node to deploy, and it will use default templates to generate networks and attach VMs to this network. And then,
so Georgie, can I stop you just for 1 sec here? There's something I want to just call out is, so this is YAML we're looking at. It looks like normal standard YAML. And yet it also looks like some sort of object-oriented coding here you've got. You actually looks like you're calling methods on objects. So could you say a little bit about that? But it's not normally how I would expect to see YAML used.
Exactly. Thank you for this question. Yes. So Murano uses DSL. So this is domain-specific language, which was specifically designed to orchestrate deployments on top of OpenStack, and it exposes the easy way of manipulations with the heat templates, which will be generated under the hood. So this security group manager add group will just go to the heat template and update the security group portion of this template. And you're right, this is a YAML format, so you can use it to actually embed Heat template snippets directly to this workflow. So you can have like Heat a resource defined here as a variable and use it to update Heat template with this Heat template snippet. And
that's very cool.
Yeah.
I like the use of this the YAML. Actually, one of the fellows that works for ActiveState is I think the inventor of YAML. I'll have to mention this to him. I'm not sure if you've seen this before.
Yes, and actually you're right. So this is object-oriented approach. So each application is a specific class in Murano DSL, and these class methods are exactly the workflows which will be executed for specific purpose. The method deploy will be executed when I click deploy button on my environment. So this will actually call the chain of all applications.deploy methods execution, and it will be not actually changed as a sequence, but all applications will start deployments in a parallel, but they will use synchronization points which are defined as a part of their dependencies. And I will actually stop here on the DA cluster. Yes, so after our node is deployed, I just ask node to set up, and this is another workflow or methods. And these methods, what it does, it just go to the VM through Murano agent and execute shell scripts, which will actually perform the actual Staccato configuration. And as you can see, we have some conditional syntax here. So this is use a XIP parameter, which was a checkbox in my UI. So this will be passed as a Boolean parameter variable accessible in a runtime, and based on this checkbox, I will do some actions. So I will actually generate this xip.io DNS name with the IP address of the node, which was provisioned by the OpenStack. So I don't know this IP beforehand, and I need to obtain this IP address in the runtime. And I will know this IP only after VM is created. So that is why I use it. I use this construction here.
So Georgie, one thing I'm sensitive about is I don't want to run out of time here, and we are getting a couple of questions about the sort of higher level. So is now a good time to check out the status of your
yes,
builds, your deployments, and then maybe I could run through a demo.
Yes, so it's actually done. So this is a deployment history. So cluster was created, and if we go here to topology page, we see those icons are green. And really quickly, I can actually change this configuration after deployment. So for example, I can add additional data cluster. So I can specify the, again, number of instances for my data. Storage, I can again specify flavors, name template, and once I click deploy, I will have deployed this big configuration. So I have my data store cluster, which I can scale up and down separately from my DAA cluster. So
very good.
Yeah, it's Murano. Yeah, and
this is very
switch and suitable to you. So there.
And yeah, hit the stop button, which is that green thing to the left of where you're at right now.
Oh, okay. Cool.
And then, so and then Georgie, I'll need the IP address or the host name of that thing you just created because I don't have it here. And then what I'll do is I'll be able to show it in use, hopefully, if it's all working. So, or what's the host name? api.something.zip.io. What can I access now?
Yes. So the actual IP address will be 198.11.214.24, and this is a floating IP, and the API name will be api.10.0.11.4.
I don't think that's going to work because that's a local address. So
no, that should work. So let me.
API dot. What was the first one? 192.124. Yeah. So I think there might be a slight configuration issue here. We had a speaker change late last night, so we had to kind of scramble a bit to get this working. So,
John, I'm sorry, you actually use wrong API. It should be 10.0, but the floating IP is different, so you need to use host etc hosts change to actually replace 10.0.11.4.
Oh, I see. Okay.
So the actual
put that in.
address.
Right, let's see if I can do this
Yes.
real quick.
And I shared the IP addresses in the chat window, so you can actually see them.
All right. So give me that IP address again. 10 dot.
No, it's 198.
Yeah.
11.
Yeah.
Dot 214.
Yeah.
Dot 24 and API dot 10.
All right. We'll see if this works.
Dot 0. Dot 11. Dot 4. Dot XIP.
Okay.
XIP.
XIP.io. Okay. Let's see if we can do this. So, and if this doesn't work, I've got a backup plan. So.
Okay. Should work. Wait.
There it
working.
is. Okay. Nice. So I'm going to create a staccato.com. I'm going to create this, and then I'll talk about what I'm doing here.
Yeah, so this is a new cluster which was just created, and that is why at the first login, John actually has to provide some user information for the first user, which will be created. And did you click create button? Okay.
Yeah, it's waiting to connect. So, and while that's happening, maybe I'll just. Oh, here we go. Good. So it seems a little slow. I'm not sure. It could be because my network here is being interfered with the webinar here. That's possible. What I'll do while that's loading up is I'll also fire up another demo.settings. So I also have another Staccato instance right here. And what I want to make sure is I can illustrate what Staccato does to the audience here. So let's see if this works. So I created a username earlier. See if I can get that logged in. And so this is showing me the web interface to Staccato. This is the Staccato instance that Georgie just created. And I've got about 6 or 7 minutes. I'm going to try to run through this really quickly. So what now? I have this web interface to Staccato, which is the abstraction layer on top of OpenStack that allows me to deploy applications. Here, I just clicked applications to see a list of the apps that are currently deployed. Obviously, there are none because we just provisioned this Staccato instance. We have our own version of the App Store. It's very similar to the Murano OpenStack App Store or App Catalog. These are applications that can be deployed instantly onto Staccato. And now, Georgie didn't provision a data services layer, so we don't have, for example, Redis or MySQL running right now. But if he had provisioned one more VM with the data services, we could provision apps that use that. But I'm just going to deploy a simple Node.js application here called Ace Editor. I click the deploy button and check a few things and just click the deploy application.
Just a second. You have to change the domain.
Oh, yes, probably do. Okay. Let's see what you're saying.
And you can use your demo environment. It
Yeah,
will be much
I
faster.
think I'll use mine for now. Yeah, just because I'm probably going to get tripped up on that. The point here, though, is that Staccato looks exactly the same. Everything you see here is exactly as if it was on this cluster Georgie just created. So I'll do it from here. This is also running on OpenStack. We have Staccato running on OpenStack out in the cloud. This one, we actually do have the data services enabled, a node here with data services. And I'll show you the configuration shortly, but first I'd like to deploy an app. So we have a Python currency converter app, a very simple 3-tier application. I'm going to deploy this out to our demo instance here on OpenStack. And I just simply click a few buttons. What this is doing is it's gathering the bits for this application from GitHub. It is creating Docker containers in order to contain this application. And it also will create containers if necessary for the data services and everything else that's needed. And then the application will be available to the user. And let's see if it's actually working, not yet. And okay, that one's still. The application will be available to the user. See here. And there it is. So it's a fairly simple app. It just has currency conversion. I select a country on each side, and it's calling out some web service to some bank or something that's determining the current currency conversion rate as of this minute. So it's a very simple app, but it actually does have a Redis data store underneath. So the point is we're looking at a full 3-tier application here that you can see is deployed with a single click. And the Staccato user interface allows us to check the timeline of when the app was deployed, and you can create forum discussions within this thing. Also allows us to track versions. So every time I push an app, and that includes the configuration changes, Staccato will track a new version. And then if there's multiple versions deployed here, I could roll back to any one of these versions instantaneously. I can inspect and change the environment variables that are associated with these applications that I deploy. I can have a look at the files that were pushed up to the app to deploy it. You see there's some Python code here, etc. WizG.pi is the actual server that's running this thing, server code. This is interesting. We can look at the instances of the app that are running. So right now, as you can see, we've got a single instance running, and it shows the IP address on which the application is, the host, the VM that it's running on. So you have a single instance, but I can turn on auto scaling here, and using these sliders, I can say, well, instead of having just one instance, I'll have somewhere between 3 and 7 instances of this app running at any one time. So as you can see now, Staccato is spinning up 2 additional instances of this application. It will now load balance between these 3 instances each time a request comes in. Now, if I was to, I don't have the time to do this, but if I was to exercise this app using Apache Bench or something, you would see that as the load increases, the number of app instances will scale up, and I'll simulate that here just by increasing the minimum number. What Staccato does is it just spins out more instances as the load increases. And then when the CPU load drops below a certain threshold, it will get rid of these app instances gracefully. So auto scaling is built into this platform. What we're doing here is we're scaling containers that are running on the existing DEAs. Now, I really want to emphasize there's another form of auto scaling as well, and this ties into what Georgie was showing earlier, where Staccato can, if we run out of resources, let's say memory, we don't have enough memory across the cluster, Staccato will call down to OpenStack to provision new instances. And Georgie earlier had set up the Staccato cluster so it had a maximum of 10 instances, and then Staccato would be then able to provision new VMs up into that maximum number. So it's all automatic, and it takes care of all that code for you itself. So anyway, right now we have these 6 instances running to handle all the requests. I should also mention the log stream. Every one of these app instances, so far 6 of them now, they each are generating their own logs, and Staccato is taking care of capturing these logs for us. You can view them in the web console, as you can see here, and it's trivial to wire up these logs so they get directed to an external logging service like Splunk or Loggly or some other data log aggregation service. Very simple to do. You can create multiple routes to this application, and back on the instance that that Georgie had provisioned, if I was to do this correctly, I'd have to take into account that new IP address. So I'm back on that now, and then when I deploy it, I'd have to specify a new route. I won't do that now because we're very short on time. You can specify multiple routes as long as they're known in the DNS. And this services shows the databases that are associated with this, with these applications, and various settings, the memory, etc. So that shows the some of the things you can do with the application. I do want to just show that. Actually, I'll show this maybe on Georgie's instance, admin cluster. And here, yes, this shows it very well. So Georgie created 2 nodes. So remember, the minimum number of DEAs he had specified was 2, or 1, I guess. So we have 1 DEA at this internal address, and then we have the core node, which has the router and the cloud controller on this address. If we were to scale it up, this list would increase, and it shows all of the roles that are enabled by each one of these nodes. And you can control these with the web interface as well, just by clicking one of these, like MySQL, and hitting save. And it will then enable MySQL on this cluster. So I won't do that right now in the interest of time. I do want to mention that everything you're seeing here can also be accessed via the API. So so here I am in my shell again. Actually, what I'm going to do is change the size of this window so it's more visible. I can also deploy an application from the command line. I've got an app called ACE, which is a Node.js application. And I can say Staccato push with an option, and it will then push this application to the cloud. So the command line API is also making use of the command line client is making use of our web API, our REST API to control Staccato. So I know I'm moving through this quickly because we don't have a lot of time, but I wanted to give you an idea of some of the functionality that's enabled with Staccato. You can, with the click of a button, you can deploy applications, and you can manage them. You can auto-scale them. We integrate security features like you can have single sign-on across all the applications deployed to Staccato, and you can also make use of external authentication systems like LDAP and Active Directory for credential management. So the point here is that many of the things that you've seen here are just managed for you by the PaaS. Things like auto-scaling, load balancing and routing, security and single sign-on, managing different versions of applications, and rolling back instantly. And there's a huge list. I could just go on and on of the things that you could do this with. You could code all this yourself just using OpenStack, no problem. But you're writing a lot of code to deal with managing Docker containers and other things. So the point is that there's a lot of functionality that PaaS provides that allows you to then focus on building your applications and not having to get mired so much in the underlying plumbing. So we're only 5 minutes left for the end of this thing. So I think I'll just, I'm not going to wrap it yet, but just last minute discussion. If any questions are coming in, I don't see any now, but if there are any, we can answer those. Georgie?
We had one. Yes, I believe we have one question from Ravi. So about the responsibilities of Stackato and Murano. So again, our use case, which you saw today, is to speed up the application developer. So Staccato Platform as a Service provides a framework to develop your application in agile way. So you don't need to provision MySQL, to provision Postgres. You just write your application, you create a manifest and say, I need MySQL database, and Staccato, when you push this application to your to Staccato, Staccato will actually take care on provisioning MySQL and binding this MySQL to your application by submitting some connections string to your application. And so what Murano does, it actually simplifies the Staccato installation. So imagine that you have your private cloud in your organization. You have different application development groups, and each application development group would like to use Staccato to speed up their application development cycle. So what your IT organization will provide, it will provide OpenStack Cloud with the compute resources which will be shared between application development team, and IT organization will provide this Staccato application as a part of application catalog. So each application developer can go and actually easily provision this Staccato cluster on demand. And each application team can use their own Staccato clusters without actually interfering with each other. Your QA team can run some performance tests or run some functional tests, while application developers will be able to still develop application on their own Staccato clusters. So this is like the bridge between OpenStack and PaaS. So we just solve the problem of Staccato on-demand use case.
Very cool. And it's all available through the user interface. And so basically just with a few clicks and typing a few in a few fields, you can provision a full multi-node PaaS cluster and get going with production development. So this is really exciting stuff, Georgie, and I appreciate all the work you've put into getting this working. And yeah, we're looking forward to moving forward with this and doing more. So again, I do want to mention the OpenStack Summit in Vancouver, where we'll both our organizations will be present, and I recommend checking that out. So great. Any last words, Georgie?
Yes, I just encourage you guys to use this Staccato application. It's actually available on the GitHub, so all this open source work. So you can actually download this Murano application and play with Staccato and use probably Staccato for your development. This is really nice open source Cloud Foundry technology, which was like packaged and prepared for you by Active State.
Very good. Well, thank you, Georgie. And yeah, I guess this brings us to the top of the hour. So thank you for all the attendees for watching through this, and we'll look forward to seeing you next time.
Thank you, guys. Stefan, I believe that's your time to